Hey, today in class, we will write down the form of a linear function and learn what the letters in this equation represent. Let's remember that in order to define a linear function, we must write down the general form for a linear function. We understand that to express the standard form, we need to use the following representation. X plus the term by plus c equals 0 value. Yet, to create the graph of a linear function, we need to represent this function in another way. We will write this equation. To create the graph of a linear function, we must understand that the linear function can also be represented differently. Y equals mx plus b. In this expression, m and b are numerical values. But what do these numbers signify? And how do these numbers affect the function's graph? The coefficient of the variable x, which is the independent variable m, indicates the slope. In math, we call this the slope. The constant b is a numerical value, but it indicates where the graph of the linear function intersects the y-axis. I will write that this value is the intersection point with the y-axis. Remember that the variable x is the independent variable and the variable y is the dependent variable. This equation can be reformulated. I can note it in the form f of x is equal to y. Then our equation can be expressed as f of x equals mx plus b. In this case, we see the dependence of our function on the variable x. But we will learn to write the equation of a linear function graph. For this, we need to know how to obtain the coefficient for the variable x and how to find the number b. In this case, this number shows where the linear graph crosses the y-axis. Then, to determine the coefficient m's value, we must subtract y2 from y1 and divide by the difference of x2 minus x. But this brings up the question, what do y2, y1, and x2, x1 mean? When we draw the graph of a linear function, we identify the coordinates of 2 points. So, if we denote point A and introduce its coordinates, labeling them as x1, y1, and for the second point B, we have coordinates x2, y2. Then, knowing the coordinates of these 2 points, we can always determine the coefficient in our equation. To find where the function graph crosses the y-axis, we simply need to check the value of b. And b is the point where the linear graph intersects the y-axis. Let's write the equation of the line. Now, let's write the equation of the line. The line's equation can be written as y nas pas 3x plus 2. We can deduce from this equation that the coefficient of the variable x, or the slope, is equal to 3. And this linear function's graph will meet the y-axis at the point where y equals 2. Thus, I will state that b normed 2. Let's talk about the properties of our coefficient for the variable x. The thing is, if the coefficient m is greater than 0, then our linear function will be increasing. If the coefficient of the variable x is less than 0, then our function will decrease. If the coefficient is 0, then in this case we get a horizontal line. For example, if I write down the following equation of the linear function y equals when m is 0, the line's equation will appear as follows. 0 times x plus b. And we know that 0 times x will give us 0. As a result, our function will take the form y equals b. But if we are already capable of graphing a linear function, then the graph of the linear function y equals b will be a line parallel to the x-axis. It will look as follows. In the coordinate system, there will be a line that goes through the point on the y-axis where y equals b and runs parallel to the x-axis. Certainly, when b is a positive value, the line that runs parallel to the x-axis will be positioned above it. In the case where b is negative, the line that is parallel will be located beneath the x-axis. However, it will still remain parallel. Today, we noted another version of the linear equation. Next lesson, we will apply this. Equation to write the equation of a line passing through 2 points. Our lesson has come to an end for today. See you later.